Alright, so this is going to be a prelude to the Skynet Edition Project 2 Milestone. I've implemented most of the AI features, except I haven't put in the waypoints yet, and I haven't fully implemented the finite state for the AI. Largely that's just because things came up during the week. But other than that, ship still moves, ship still shoots. I took some time to retune the firing because it wasn't working the way I wanted it to. As you can see, the AI now tracks and shoots at the player. So of course when the AI starts shooting itself in the nose, which happens sometimes. But that's neither here nor there. The AI is currently not moving around, even though it has all the same features and functions. You can see that the bullets will blow each other up when they collide. But other than that, yeah, that's just because I'm using the explosion on destroy. But as you can see, here's the ship 4. It contains character controller, capsule collider, tank physics, tank health, tank controller, tank data, AI controller. It has the field of view script. It has the pawn script. It even has a very nice little that's just to shoot the bullets. Here's the ship itself. There's the character controller. There's the box collider that I use in order to simplify it. There's the tank data. There's the input method. Tank controller, the tank physics, the tank health, the player controller, the pawn. So you can see that it has all the same features. Here's the avoidance setup. It follows directly along the same lines as the rest of it. The chase. This is what happens if it runs into an obstacle. For this one, I am probably going to add something so that it doesn't return a raycast hit on its own. On its own bullets, because that would make it think it's being blocked when it's not. It's neither here nor there. It just does for the fire the cannon. As you can see here, it switches AI states. I just haven't put the AI states into the central AI controller up here, which is a switch. And there's my finite state machines. It has 4 possible states, and then it has the fleeing, and it has avoidance, and it has current AI state choice, hostile gunner, where it tries to follow the waypoints. As you can see, since it's always getting a false from my football helmet, it automatically switches into hostile gunner, which is what you were seeing when it first started. So it goes directly to do some shooting. That part's just to make sure that if the player gets destroyed, when the player respawns a new object, it's able to track that new one. Do some shooting is just very straightforward. It tries to rotate towards the player, and it fires the cannon. The simplest thing I could do to improve this one would be to make sure it's not trying to fire the cannon at a target outside of the engagement range. But yeah, that's pretty straightforward. Here's the code to follow the waypoints. All it does is it tries to move towards the waypoints, and if it can get to that destination, it will turn towards the waypoint. So yeah, I have a good portion of the code put in. I just haven't implemented it by tying it together up here. And here's the text describing what it does. Switches to being an immobile gunner if it has no waypoints. When the ship is generally just patrolling or loitering, it switches to an immobile gunner if it has no waypoints. Dive bomber, the purpose of dive bomber will just be to send it at the player. So what it does for that is it would just enter into the chase mode. So it would not do that. It would do chase. That's all it would do. And then this one would do chase as well. They both would use the same state to do it. The only difference with Dive Bomber is it would do chase, then it would do avoidance. Because it would try to like swoop in, get into like a third or half of the engagement distance, then switch to do avoidance. But that's about it. Here's the field of view. It just pulls the variables that it needs for it. This one actually uses layer masks in order to try to set up a visual representation of it. And all that does is this is just going to cover the visual display of determining whether or not something is there. So I have field of view. I have the ability to identify if something's nearby. Physics overlap sphere. It uses the overlap sphere in order to find if something's nearby rather than iterating through the list of various game objects or player objects in order to determine where something is based off of its global position in relation to where my ship currently is. This one just uses the overlap sphere in order to determine what's inside of a given radius for the ship. And what that does is it will return collider, it will push items into the invisible range, visible targets list, and then it attempts to go ahead and raycast towards those targets. And if it can hit the raycast, it knows that they are within visible range. The only real difference between a listen is this would be using the, instead of using view radius, it would use listen radius. And it would be targets within ping or something, which is fairly common. The other way that I do with that is that, because, see, this is the other method that you use, like I was talking about earlier, is the vector 3 position equals this dot this player ship, and it can hear the player already. So, vector 3 position equals this dot this ship transform dot position. Then it finds the difference between the player target dot transform dot position minus this one's position, and then it gets the square magnitude of the difference in the distances between the two. And then if the difference in the distances is less than or equal to the hearing distance, then it can hear it. So it'll switch the current AI behavior choice to hostile gunner. So it's already implemented. This one is fairly simple. If I don't have any waypoints to follow, then it goes ahead and switches out of my football helmet. This is the flee behavior that I haven't implemented yet. This one would just do a move away, because it would switch the after them, which is going to be a free-floating vector. And all that's going to do is it's going to make sure that the enemy ship attempts to move in a vector that leads directly away from the player. There's can move, there's do chase, there's do avoidance. And that's pretty much it for the angle controller. The only thing special about the way I'm implementing field of view is I've actually implemented a visual aid in order to draw field of view, so that when I begin troubleshooting the AI seeing things or hearing things or doing things, I actually have a GUI representation that lets me see if it's seeing through a wall it shouldn't see through, or if it's not seeing me when it should. And that'll just be very helpful for troubleshooting it. But otherwise, everything else is pretty much the same. Here's the independent pawn. Here's the cannon shot, which just goes ahead and spawns a bullet that it fires. Here's the bullet itself, which just goes ahead and runs the updates in order to move the bullet. There's the coroutines that it still uses. There's the tank controller, and all the tank controller does is call the pawn. And the tank controller itself can be used by the AI controller or by the input controller, the character controller. And then here's the game manager with its numerous variables. One of the things I did, because I didn't want zero values for certain things, is I went ahead and declared a range on them so that it's actually impossible for them to start off with 0. Enemy viewing angle, for whatever reason, actually can equal 0, because the enemy could theoretically be blind. So leaving it like that is fine. So then going back over here to Unity, though I didn't really change anything, we can go ahead and see the inspector over here. The difference factor hasn't been implemented yet, but it'll be used to change the various differences between the numerous ships. Right now I just have one enemy AI ship implemented, but the main thing for that is due to the fact that the enemy ship can actually have 5 different AI states. So it said we were supposed to have 4 different enemies, but I have 5 different finite state sets that a single ship can have. And graphically I haven't implemented it yet, but I have all the assets that I need for it. Because as you can see here, I have all these various assets that I just would need to staple the scripts onto. So yeah, it's pretty much the same. I shoot it, it blows up. I move around in the 3-dimensional space without much problem. When it tries to hit me, you can see right now, because it doesn't have any waypoints to follow, it just automatically switches into the hostile gunner mode and shoots at my ship. But like everything can be controlled from it, and you have the nice sliding bars because of the fact that I used the range in order to determine stuff. There's bullet speed, there's bullet duration. Probably should just turn that down to like 4. This is the masking that's used in order to do the culling for the field of view. That's just set to layers, because like this one, you can see it has the layers set to asteroid. So when we go back to Game Manager here, you can see that when we go to Field of View, that it will actually cull, because obstacle mask is set to these hurdles, and that comes from the Game Manager, and the Game Manager is setting the obstacles to be in the asteroids, and the target mask is going to be equal to these players. So that's very straightforward. So all that it has to do in order to get things to fire is that it would do start coroutine, find targets with delay, looks this often. So every time it would go, it would fire the this I enumerator, and the I enumerator would return the Boolean values from whether or not it was able to find anything. And this would just give me a list of the various visible targets that I have. So if there was multiple players, it would actually return multiple players simultaneously, rather than absolutely knowing where every player is on the map because it has a reference index for them. It would check to see if they were within its visible range by trying to throw a raycast at them. So not only is this less process intensive than going through all the game object lists, it's actually makes for a more realistic dumb AI. Because with this, it doesn't absolutely know where you are until it can actually lay eyes on you, which is neat. Even though right up here, it's able to tell anything within the listening range. So it's a little bit more efficient, but not by much. And this just spawns the player. So that pretty much covers it for this session. I didn't get in everything implemented that I wanted it to get in, because I'm going for a slightly more advanced implementation when it comes to the finite state machines, and I want to use a bit more complex logic for it, but I should have it in by Tuesday, Wednesday. I just had a bunch of family stuff come up over this past week and weekend. Well, thank you for the time.